Hey guys, um, I hope you all had a great weekend. I'm recording this on Sunday night, so hope you had a good weekend. All right, so I'm gonna pick up where we left off on Friday. Viruses cause a variety of infectious diseases such as common cold, influenza, and SARS. SARS is an example of coronavirus. Influenza can also, that's a different virus. And then common cold can actually be a couple of different viruses. It can cause it. I mean, a couple different types of viruses can cause the common cold, like coronavirus, but there's also other ones. Oh, there's another one, sorry. Okay, I'm gonna skip that. Okay, so the human body has a natural immunity to viral diseases. Skin and mucous membranes are kind of a way to maybe not get the virus inside of us. Our skin obviously keeps it outside, and the mucous membranes, like our nose and eyes and stuff, and our mouth, try to keep some of it away. And like some of it can be trapped in like boogers, basically, nose hair, stuff like that. We also have macrophages, such as white blood cells, that help fight off these diseases and viral diseases. And then we have B and T cells, which create antibodies so that our body knows when we've had that disease and they know it's a danger, so they fight it off. Um, they're talking a lot about that right now with coronavirus. Is once you've had it, they're going to start testing, or once you think you've had it, they're going to start testing for antibodies because they think they still don't know because all this is new. They think that you won't be able to get it again because once you've had it, you've had it. They don't know if that's true yet, but that's what antibodies do. Antibodies basically say, whoa, 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 I've had this. I know how to treat it. Let's get rid of it. So that's a good thing. Viruses evolve as our bodies become immune to them. Example, HIV. Um, HIV starts out differently and then it turns into AIDS. So that's how it's different. Um, influenza is really different. I mean, usually once you've had it 1 year, you can't get it that same year again. But then there's always changing. And so, like on this picture right here, it shows the more virulent, the more it attacks you, less chance of transmission to other people. And then if it's less virulent, you usually go out and transmit it to other people. So that's kind of like what they're trying to make us do with this right now is it can be very virulent, so we want to stay home so there's less chance of transmission. So some viruses contain viral oncogenes. That oncogenes is things that cause cancer. Genes which block cellular control of its own reproduction and can lead to cancer. So some viruses basically say, okay, reproduce, 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 which you know from a couple chapters ago that over reproducing cells, like if there's nothing to stop it, they'll keep reproducing and reproducing, which causes like tumors and cancer. And so some of these viruses can actually cause cancer. So other viruses cause cancer because the viral DNA inserts itself near a prototype or a proto oncogene. So some of these viruses can cause cancer in different ways. Some of it's just they keep replicating over and over, and then some of them the viral DNA inserts itself into the to near an oncogene. Because viruses are lifeless particles, let me go back to that for a second. One of the ones that causes cancer the most, and that we talk about, or that needs to be talked about the most, is crap. What am I thinking of? The shot. Oh God, I'm totally blanking. The one that you're supposed to get between your 11 and 12. It's not herpes. It's a sexually transmitted disease. Um, oh my goodness, I'm gonna come back to that, but I cannot remember what it is. But that does cause cancer. Um, okay, so because viruses are lifeless particles, their spread depends on agents. So, like the West Nile viruses and all of those are done by a pathogen, which is a mosquito. That's the answer to that one. The pathogen is a mosquito. West Nile virus, Zika, dengue fever, all of those are all caused by a pathogen as a mosquito. So the vector in this, what actually transmits a vector is an immediate host that transfers the pathogen. So a host is something that has it, or a parasite or another organism. So the vector is basically what transmits it through a host to us or other organisms. Vectors include humans, animals, mosquitoes, ticks, and fleas. So we can transmit it to other things, uh, other organisms. Animals can transmit it to us, mosquitoes, all that kind of stuff. Ticks, all that kind of stuff. You can get Lyme disease and all that from ticks, fleas, plague, and all that kind of stuff. Emerging diseases are illnesses caused by new or reappearing infectious agents that exist within animal populations. So these are basically emerging diseases that are new or reappearing because of animal populations, usually because they are encroaching in our wildlife or we are encroaching in their habitat. Examples of this would be Ebola, hantavirus, and SARS. SARS, if you remember, was transmitted through camels. Oh, that was Middle Eastern. Sorry. SARS was. Ooh, I can't remember. Wild and domestic animals can harbor viruses and can be transmitted to humans. So this could be mosquitoes. This can be ticks. This can be cows. Remember mad cow disease? It can be anything like that. The close interaction of animals and humans can lead to the disease transfer. So again, as we encroach on animals' populations, I'm going to say that, we can transfer all these diseases. Vaccines are made from weakened pathogens. A vaccine stimulates the body's own immune system. Weakened pathogens are what causes the disease. Okay, so again, with the question on West Nile and Zika and dengue fever and all that, the pathogen is a mosquito. All right, so vaccines prepare the immune system for a future attack. So vaccines, one way that they can help is they'll go, oh wait, I remember that. Now I know how to attack it because I've already had that before. I've already been I already have a response to that. So like when we get the flu, okay, and let's say the shot works that year. If you actually come in contact with the flu vaccine inside your body will go, wait, I know that one. Here's how to attack it. Okay, so that's what vaccines do. Vaccines are also are the only way to eliminate the spread of viral disease. So we need these vaccines to keep all these viral diseases from spreading. So chickenpox, again, we get the shot between 12 and 18 months. Hepatitis A, they're actually giving this as babies too, but this is contaminated with it's contact with contaminated feces through food, water, whatever. And then mumps is the MMR shot, your measles, mumps, and rubella shot. You get that a couple of times between 12 and 15 months, and then again between 4 and 6 years. Let's see. Rabies, that's infected animal, a bite from an infected animal. We don't get, humans don't get rabies shots, but veterinarians and biologists who work with animals can. And then the West Nile virus, again, there's no vaccine for it, just like Zika or dengue fever or any of those. You can't. There's no vaccine right now, but the bite is it's from an infected mosquito.
Who owns the patent on this vaccine?
I'm gonna stop this. Okay. All right. I'll see y'all or talk to y'all later.